Welcome to this presentation on terminal tools. Before I get started, just wanted to make a quick pitch. If you guys are interested in a copy of PostgresOpen Administration Cookbook, we are trying to get rid of them at the second quadrant booth. If you're willing to pay to take one home, it'll also come with a signature from one of the authors, Simon Riggs. But with that, this presentation will go over some terminal-based tools. We'll give you some basic live views of the system. It's intended to be a simpler, quicker thing to use than PSQL or a GUI where you have to get in and type some commands. Well, not necessarily faster than a GUI if you have some point and click things to get you what you want to see quickly, and it's meant to be a complement to whatever tools you have in place, not necessarily replace anything that you have. So I'm going to go over what the capabilities of some of these tools are. But before we get into that, a little bit about me. My name is Mark Wong. I'm employed by Second Quadrant. I've been involved in the community for well over 15 years, I think, at this point. Been recognized as a contributor for a little while. I'm also a director of a small nonprofit called the United States Postgres Association for a little while. And if any of you are in Portland, I also get involved in the Postgres user group up in that area, helping organize presentations and whatnot. So I'm going to go over a few tools, but I'm actually kind of interested. Are folks here mostly using some kind of GUI interface now? Or are you guys pretty stronger with using the terminal and so forth? So what I'm going to go over our tools. Oh, and another question too. I am curious. Anyone on BSD or BSD has Postgres on BSD specifically, or Windows? I'm going to point out now that most of these are really going to be for Linux. PG-top on the top did used to work better on BSD in earlier days, but that comes down to having development time to keep up to date with the changes in the process table. So I do want to point out now that not to say that they won't in the future, but these are really primarily developed on Linux and getting some system statistics need to be ported to other operating systems. So the first two tools on here, PG-top and PG-systat, are actually really the terminal applications. What I have on the bottom, PG-proctab, is an extension to Postgres to really just expose the operating system process table. It's not really a tool in itself. It's really something to give you access to script things around. So I'll go over some of those, but it's really going to focus more on the first two to get process information and get access to the Postgres statistics tables. So PG-top, as clever as it is named, really is based on a typical top utility. A lot of people have heard of top before, used it, yeah. And while I have these screenshots here, I knew that they were going to be too small, so I planned to get something a little more, hopefully a little more readable and maybe more interesting. So for the, was there really only one BSD user back here? This one is actually ported from the top from that you would recognize in BSD with a little bit of cosmetic changes. So what we have here is a live display showing what the system load average is, the number of processes, and I see I have a counting error somewhere. We have 27 Postgres processes specifically. This is focused on what the backend processes are, or not displaying anything other than what the Postgres backend processes are. So the 28 number is correct. The number of idle is not, but it's also meant to give you a count of the state of the current processes running, where you have 20 of them active and we have 1 idle in transaction. A summary of the CPU utilization. Including the I/O wait time. Summary of the memory used and the amount of swap that is currently available or being used. So where we start to differ and I'm hoping this should, what I don't have is sorry. So what we have the PID, as you would expect, to be reported what the backend processor ID is. The username here is not the username of the person who owns the process, as you would expect from an operating system point of view, but instead the name of the database rule that is connected to this backend process. Size, the memory size and the resident memory size are the same as you would expect from an operating system point of view. The state of the backend, which is actively processing, and the transaction start time and query time of what is running on that backend. The CPU percentage of what is going on, or of how much, the percent time that backend is on a CPU, the count of locks. I guess I'll have to make this a little bit smaller. Number of locks held by that backend. And trying to make my window a little bit bigger here. What we show for the command, I think what you may expect from a top program, what the name of the process is that's actually running. So in Postgres, it's the postmaster. But you can toggle this to show in Linux what is called the full command line. But how Postgres reports the full command line is the name of the program, which, well, for whatever reason, depending on, I think, how the binaries are linked. You saw it was postmaster previously, but Postgres reports itself to the operating system as Postgres instead of the postmaster. You'll see who on the upper ones, or the majority of these lines, it's the user Postgres connected to the PG Bench database over a local connection, whether it's running an idle, update. It's a little truncated in this because of the size of the window, idle and transaction. It'll show your auto vacuum workers also. Oh, yeah, key press to cycle through that. So I can go back to Oh, and I didn't to show the next view that you can toggle is the current query of the process coming out of the pgstat activity table. It gets a little formatted, reformatted here. I'll pull this over a little bit. So in case folks were wondering, some of you may recognize that this is pgbench running in the background. The query that is reported here, if you notice some of the question marks, there's probably a cleaner way to do it, but what it's doing is it's reformatting the queries into single lines and stripping out control characters that may not be so friendly for a terminal. So yeah, cycling through, we can get back to the basic brief process name or the full command line that Postgres will report to Linux, or the actual query that's running. So now other things that may hopefully be, or that I assume you'd be hoping for, is that we can sort by either by most of these columns. So if we wanted to see what were the longest transactions running, you can see that someone has logged into, has connected to the database, started a transaction about, what is 380 minutes? Hours ago, right? You can see who that is, what database that they're connected to on the top. I suppose that would be me connecting to Postgres, the database name Postgres, idle and transaction. A couple of other things that you can do is you can also look at get a little more detail on what the process is doing. So if we wanted to see what the current query of what this guy is running, well, he's idle in transaction, so he's not going to be running a query. So I'm going to pick one of these other processes which is connected to pgbench. Oh, okay, I picked the pgtop query itself. Let me find something. Just spawned. That was just by chance there. So you can look at the query in full, and assuming that you catch it in time, which I got pretty lucky here, I think. So it'll show you the query unformatted. One thing to keep in mind that there is a setting that I can't remember offhand. How many folks have had to deal with trying to look at long queries and see them truncated? So I think, and I forget which version, I'm willing to wager that it's going to be version 9.6 or 10, that you were able to set a database parameter to increase that to larger than the 1 kilobyte. I think it's a 1 kilobyte default. So if you are running some massive queries, you should be able to see all of it if you have a need to increase that. Another thing that you can do is, oh, I don't want to rerun. Oops. Check out, if you had a long-running query that was running there for quite a while and you wanted to see what the execution plan is. Oh. So why is pgbench having a syntax error on end? I don't know, but if you'll allow me to make a couple more tries on, I think this was the, yeah, so this is pgtop. It'll show you what query it's currently running and run explain and display that for you. There, you could also run an explain analyze if you wish. I hope folks are familiar with the danger of rerunning long-running queries with explain analyze, but just for demonstration purposes, I will go ahead and give that a show. So it's running explain analyze, showing the planning, execution time. I will shrink this a little bit. So on the far right, oh, refresh error. Showing the actual time, execution time of what the query is. Another thing you can do is look at the locks held by a process. I think the same process would be a safe one. So this was, the query is not reported here, but this was the same process. Oh. This is the PG top process querying PG stat activity and all the other tables that it needed to access in order to, well, all the locks against, all the tables that it had to get locks against in order to query all the stat activity information. So you can see the type of lock that was needed for what to the associated table and whether it was granted. So if we were to have found a process that you were wondering what it was waiting on, or that you were wondering what it was waiting on to acquire a lock, hopefully this will help find that information for you. So that's, a couple more views here. So in addition to the process information relating to size, memory size, the memory utilization, transaction times, and locks. On Linux, we can also get the I/O information per process. For those of you who are used to looking at, or I should rephrase, the column names may be a Linuxism. The rchar, wchar, syscr, syscw. It's basically the number of, as it's reported here, it's the volume of I/O that's requested to the operating system in the first couple of columns, whether or not it's actually retrieved from the system cache versus, whether it's the sum of the data that's coming from the system, operating system file cache and storage, followed by the number of I/O requests, the read and write requests. And the reads and writes refer to the amount of data that are actually coming from disk. So in most of these, we see the read requests, rchar, and the system read IO, read IOPS, are not actually pulling data off a disk. Those are all coming from the operating system cache. Make sure I heard that right. You're asking if this is a separate utility than PGTop? This is, PGTop is running on the same system that the database server is running. Did I,
Yeah, I mean, I was just trying to find out like we use AWS RDS very frequently, so will it help us in any way?
Oh, sorry, I still didn't quite hear all of that.
Yeah, AWS RDS is like a managed service. We do not have access to the whole underlying code.
Oh, yes, yes. So he was making a comment about running on AWS RDS. So yes, you wouldn't. I will touch on that a little bit in some further slides. So yes, running PG top like this wouldn't be able to get the systems, some of those system statistics from an RDS system. Oh, PG top has been available for a while. Yeah. But there are some recent updates in recent over the past few months. Was there another question? All right. So similar. Oh, that was someone back there. Sorry. Similar to the other view, you can also sort by most of these columns here. So if you wanted to see the, either I have a bug or I didn't type what I thought I did. I was trying to sort by the right wchar column. That doesn't look too sane, does it? Let me try a different column. Oh, that also doesn't look too sane. I must have a bug in there. When I get that fixed, you can sort by column to see what is making the most read requests or write requests, and hopefully track down what the back-end processes, what back-end process may be doing the most writes, for example. And then similar to the other view, it will show the command that you can toggle through to see the query that's running. The process, the actual binary name is probably not going to be as helpful in those scenarios, but in this case, if you will allow me to say that the background writer was creating the most write I/O requests, then it would be revealed here. Another view that we have is the view of the PG stat replication table. So this one, to keep it readable, it will show the, I will go ahead and actually shrink this a bit. And I think this is going to need a little bit, some information trimmed from it. Is that pretty small for you guys? Showing the user that's doing the replication connection, the application name. If those, for those of you who are familiar with Rep Manager, that's what was used here to set up standbys. What's shown under the application PG2 and PG4, those are the names of the nodes configured for Rep Manager of the replicas that you set up. So what Rep Manager is doing is it's using those node names as the application name. It'll show you the IP address of the replica shown as the client, the state that it's in streaming, various information about the LSN, I'm sorry, I'm drawing a blank on LSN, the transaction log location ID identifier. And then to the right of that, what the replication lag is for the replication of the what is sent, what's been written, flushed, replayed. And one I wanted to show here for hopefully some good interest is that you may have noticed there is a PG3 missing, and that is because I had a node shut down. And I'm going to try to bring it back up and see if it gives us some interesting numbers. So PG3 is up, it's catching up. I will try to sort by, okay, that one seems to be sorting okay. I decided to sort by the right lag. Depending on how many replicas that you have set up, hopefully this will help keep an eye on what the current state of your replicas are if you needed to figure out who was behind and how far behind. All right, so that's PG top in a nutshell for system stats. I'm going to fly through some of these slides. A couple things I wanted to mention is, while that is intended to give you a quick view of the system, that there is a batch mode operation, as some folks may be familiar from using top, to be able to just capture some of that output into a text file. And again, not to say that this is meant to replace other monitoring that you may have on the system, which you hopefully all do, but something maybe quick and dirty if that can be helpful at times. There is, and then now touching on one of the extensions I mentioned earlier, this PG proctab extension is a Postgres extension that can be loaded to expose operating system data. So if you had this extension loaded in a database, you could connect remotely to that database to get the same CPU, I/O information without having to log in to an additional system. Unfortunately, this won't fix I presume won't fix the RDS scenario unless, for some reason, unless Amazon provided this extension that would expose the process table information from RDS. So to now show off PG Systat for a little bit, this is another utility that was ported from BSD as a way to show statistics from currently the PG stat database, PG stat all tables, or tables, indexes, the stat IO tables, and the process vacuum table. And again, I have hopefully an interesting live demo. So I'll go through the views here. As a quick thing for those of you not familiar with BSD and Systat, this should look fairly similar. On the bottom, it has a list of all the views, which you could start up in any particular view that you wanted to, but I am going to kind of scroll through them just to also as a combination of a review of what's in the PG stat tables and what it'll show. So in the view that we're in now, it's from the PG stat database view, showing the databases, the number of connections to each database, what the current rate of commits. It looks like I'm refreshing every second right now, so it's showing the commits done in the last interval and normalizing that per second. For commits, rollbacks, showing the amount of deadlocks. Also from the same pgstat database table, it'll give you the number of read requests from the, I think I'm saying this wrong. The number of buffers read in that database, normalized per second, the number of those reads that came from shared buffers, giving you a hit percentage. Also I'm drawing a blank on the read-write time, but it'll show you the number of temp files, the size of the temp files, or the total size of all the temp files that have been created. This view is not as interesting as this should actually be run against a standby, and I don't think I have a standby in a state where there are a lot of conflicts going on. But if you were having trouble with wondering what an issue may be with a replica, seeing if there might be some lock contention between table spaces, between buffers that are pinned in memory, deadlocks, which may be related to why a replica may or may not be keeping up with a primary. Going on, this view is showing, it's actually not really from a PGStat view. What this is doing is showing all the table spaces defined in the system, which I only have the default and the global, where they exist on the file system, to let you keep an eye on the size, how much is available, and the percent used on the file system. More data from the PGStat database table, number of reads and write requests, how many rows were returned, fetched, inserted, updated, and deleted. Give you an idea of the rate of activity. Then we get into the PGStat tables statistics. These are, indexes first. Sorry, these are the indexes first. I will try to keep the numbers large, hoping that'll be easier to understand than seeing the full names. But it'll show you the schema, index name, the table that index is on. So the columns that's being reported in this particular view is the number of index scans, the number of rows that have been read and fetched. And there is a key toggle to sort through the names, go through and change the sort order of each column. So this one is, I think this one is sorting by the number of scans. I'm wondering if there is a bug, but I'm not sure why a couple of those columns are static there. So to help, or it's not sorting on what I think it is. I know one thing that this lacks is giving you an easy identifier to see what you're sorted on. But to help give you a view of help you identify what the biggest or most utilized, what your busiest index is at the moment. More index statistics. This one showing the blocks that are read, blocks hit. Doesn't give you a calculation of hit rate yet. This view on the, I think this is a table view, yes. So this data is coming from the PG-stat tables about indexes, showing the number of rows modified for the table, showing you the schema and the table name. Number of rows modified when it was last analyzed, auto-analyzed, what the current analyze count is, and auto-analyze count since the last auto vacuum run. I was just changing that size. What it's showing is the full timestamp, which is getting truncated just because of the size of the text. But if your monitor was big enough or the text size was small enough, you'd see the full timestamp. More stats from the PG stat tables showing the number of blocks read from the heap as well as the blocks hit. Well, read from the total number of reads and the reads that were going to the operating system and the reads that are actually hit in the shared buffers. Then in the next view here, it's showing the same numbers for the blocks that are coming from blocks read coming from the index, or sorry, the read requests for the index going to the operating system versus the index reads to the index coming from shared buffers. And again, for those numbers specific for the toast tables associated with the table in question. The previous one were the indexes for the toast tables, and here are the number for the toast tables but these runs on the small run on PG bench is not going to show any interesting numbers there. Then on this view for the tables, it's showing the number of sequential scans, the number of rows read, the scans across all the indexes associated with that table, and the number of rows fetched from the index. Additional table stats show the number of inserts that were made. The number of rows inserted, the number of rows that have been updated, number of rows that have been deleted, and the number of hot updates, how many rows are known to be dead, how many, show you the live rows first, and then the number of rows that are dead in the table, which could be helpful for vacuum-related analysis. And similar to the vacuum statistics for indexes, we can browse the vacuum statistics on each table when they were last vacuumed, auto-vacuumed, what the vacuum and auto-vacuum counts were since the last statistics reset. This view here that's empty is the vacuum process. If I didn't come up with a good way to get a long-running vacuum going to show what tables were being vacuumed, but this view will hopefully be helpful in giving you what the state of the vacuum is, the running count of how many blocks that has been recovered. I'll make this smaller to show how many heap blocks total have been hit, how many of those were scanned, vacuumed, similarly with indexes. Giving you a count of the dead tuples touched and so on. And so those are the statistics table that PG Systat will help you browse through, hopefully on a easier basis than typing in queries. Then jumping through my screenshots again of the same stuff. PGSystat also has a batch mode that you can use to quickly capture the data per view. Have a lift out a small note. You can, when you're running this on the command line, you can select, or you should select the view that you want to capture data from. It is only going to capture data from a specified view or the default, what the PGStat database table is, that's specified as the default. The other thing about this is that since it is just querying the Postgres catalog tables or the statistics tables, this is something that can run against a remote database, other than with the one exception of the view that's looking at the table spaces, which will need to have file system access to show you the space used and available. Oh, if I heard you correctly, how would you run the command to connect to a remote database? Yeah, so pgtop and pgsystat is with the command line options. I'm trying to keep close to what you would be familiar with PSQL, so you could specify the same -U for username, the -D for the database name, H for host, and port number. So then in the remaining few minutes, I wanted to mention pgproctab a little bit, what this extension provides. It's really just 4 functions that will get the CPU time, the low-level kernel ticks reported as you would see if you were to go and cat those /proc endpoints in Linux. So the CPU time, what the load average numbers are, what the various memory usages, and it will traverse the process tree also to gather statistics on each process. But not to wade through all of those in great detail, what I wanted to point out here was that given those 4 functions, it is possible to generate some reports based on what a particular PID may have done, given that you're taking snapshots of those of the data coming from those functions. As a side effect, if that's a good way to put it, is if this extension is loaded in a remote database, you could use pgtop to connect to a remote system with this extension loaded to get all of that information and monitor system statistics remotely. So it is, Linux is the platform that I do primarily work with, so it is not unheard of to get statistics out of a Windows or BSD system or any other operating system for that matter, but may need a little help if that's something folks may be interested in. So I'll go over a couple of details, a couple of the reports you can generate real briefly. But there are some scripts included with pgproctabs that'll give you examples on creating some tables to store the data from, or if you're going to use a database as a data store, if you will, to store the system statistics information, the PGStat table information and the system statistics information. Then having that data, you can start generating some reports from that. Looks like I have a slide out of order here. Just really briefly, what is going over some of the example scripts. There's one script to create the tables, one script to collect snapshots of that data, and so if you were to create the table, keep running the script the SQL script to collect that data. Then what you can do is run some of these other scripts that are provided to report what the process utilization is of a particular backend identified by its PID. You give it the snapshot. When you run, using the previous scripts, when you run the script to collect a snapshot, it'll give you a little ID number, so help you remember what it is and when you ran it. So a contrived example, we had a PID report, or we had a PID use 42% of the CPU time in whatever interval that you've collected data over. You can also get some I/O statistics, how many read IOPS, read-write IOPS, the number of bytes read and written to between those two intervals for a given process. And in additional script, this PS report example that's thrown in there, it'll tell you what database that you were getting the statistics from for this given PID, give you the timestamp of when the snapshots were taken, how many commits, rollbacks were done at that time, how many reads and reads to the operating system were requested, and how many of those hit the shared buffers over the same interval. Real condensed example here for readability. Then it'll also go through the tables in the database that you were connected to for that PID to report some of the same, basically the same statistics that we saw in PGSystat, the number of sequential scans, index scans, rows retrieved, inserted, update, and so forth for a particular table. Similarly with the index. And that's what I had prepared for you today. So with a couple minutes to go, thank you for listening. I'm happy to answer any questions. And I know it's the end of the conference, so I will try not to hold you too long and let Stephen get back up here as soon as he can to finish with the closing. Thank you.